Welcome back. This is Dan with the Rensselaer Polytechnic Institute Engineering Ambassadors, and I'm here with our last video in the 3D printing and engineering design video series. In Module 3, I will give you your second engineering design challenge. You will have to design a wind turbine to generate the largest amount of electricity possible. Today we're going to talk about four main topics. First, we will give a brief history of wind power. Then, we'll discuss how the energy is actually harnessed, what role engineers play in making it all work, and then the future of wind turbines. Many of us don't really think about it, but we've been harnessing the energy from the wind for hundreds of years. We do this in the form of sails. The sail captures the wind and it propels the boat forward. Slide 5. Later, we created windmills, which converted wind energy to mechanical energy. This allowed us to perform simple tasks such as pumping water and grinding grains. It wasn't until 1887 in Cleveland, Ohio, that we first created electricity using wind energy. Pictured is the turbine. It only produced about 12 kilowatts of electricity, which is only enough electricity to power about one house per year. It was only about 60 feet in diameter. You can see a person mowing the lawn in the corner as a size reference. Modern wind turbines are much bigger and much more efficient. They range from about 150 to 300 feet in diameter, which is roughly the size of a football field. They are usually grouped together in areas called wind farms, which are collections of usually around 100 wind turbines. Each one of these can produce about 3 megawatts of electricity, enough to power over 300 homes per year. That means each wind farm can produce enough electricity to power over 30,000 homes per year, and it's completely green. Now that we've talked a little about the history of wind energy, let's talk about how it's actually harnessed. Of all the power used in the United States as of 2011, less than 5% of it came from wind energy. There are many difficulties associated with using wind energy. It needs a lot of space since they are massive structures. Engineers are trying to find new ways to improve and integrate this technology into the world to hopefully increase that percentage. Fossil fuels such as coal and natural gas make up the bulk of our power sources, but fossil fuels have a lot of negatives associated with them. Burning coal and other fossil fuels for power pollutes the environment. Wind energy is a viable alternative to these harmful methods of power generation. Wind energy is actually very efficient because the mechanical energy in the form of the turbine blades rotating is converted directly into electricity. Instead of using a power plant to create the electricity like other methods, the electricity is created right away and is put directly into the power grid. Unfortunately, there is a big problem with wind energy: the wind. We can't trust that we will always have wind or that it will be strong enough, which means we don't always produce electricity. It also means that the amount of electricity we make using the turbines varies depending on the wind speed. There are three main types of turbine designs. Each design has advantages depending on the wind speed and direction. The wind turbine pictured in the middle is the most common type, and is the design you've probably seen most often. The design on the right works well in turbulent winds, and the design on the left doesn't generate much electricity, so it is mostly used for measuring wind speeds. Now, let's talk about what roles engineers have in designing turbines. Engineers are constantly trying to understand and design better turbines. One of the biggest problems is getting enough wind speed. Some of you may have experienced something called turbulence while flying in an airplane, and turbulence is essentially choppiness in air. If we look at low altitudes, we have houses and trees that block the airflow, chopping up the air. So engineers realize that if we put the turbines high up over all of these, we can get smoother air to spin the blades more efficiently. This will in turn create more electricity. It turns out that the wind is a lot stronger the higher you are. Engineers know this, and they can put the turbines high up in the sky to get higher wind speed to get higher energy production. It's great that we were able to design larger turbines that can generate more electricity. However, this brings new issues such as transporting these blades. If I was to use a turbine in Texas, but I wanted to build it in New York, there would have to be many engineers coordinating the transportation of these parts so that situations like this don't occur. Engineers are still seeking solutions to challenges in wind energy. Engineers are looking for safe solutions to noise, structural problems associated with the vibration, and ways to take advantage of low wind speeds. Now, let's wrap up our discussion on wind energy with the future of wind energy. Engineers are incorporating wind turbines into the designs of their buildings. On the left, you can see a building that funnels the wind in between the towers to create electricity. On the right is the Strata Tower of London, which uses the idea that higher wind speeds are found at higher altitudes. The turbines are at the very top to get as much electricity as they can. What's interesting about both of these buildings is that the power goes straight into the grid instead of going to a power station first. Here are two futuristic ideas of how wind energy could be generated. On the bottom left, the wind is generated by the cars passing underneath, which could power some streetlights or highway signs. On the right is a picture of a helium balloon, and in the middle is a turbine. The idea here is again to use the high wind speeds at high altitudes to capture a lot of energy. As you can see, there is a long way to go with wind energy technologies, and we're only scratching the surface. There are so many new ideas that engineers are testing, whether it's the mechanical engineers helping to design the blades, or the material engineers to help make the materials for it, or software engineers to program the circuitry that the electrical engineers build. There are so many different types of engineers working on this problem, and it will need to be solved as soon as possible. Now, you are going to act as an engineer designing new wind turbine blades. The goal here is to generate the largest amount of electricity possible. But before we dive into it, we want to discuss a couple important ideas to consider when designing your blades. The first thing you need to consider is the pitch of your blade. The pitch of your blade is the angle at which the wind is going to hit it, so it can be perfectly perpendicular, where there is a lot of surface area, or it can be completely parallel in line with the wind, or maybe at an angle. You are going to test this out and see what works best. Another consideration is the shape of the blade. The top picture is a whale's fin, and engineers sometimes look to nature for inspiration for their designs. A whale's fin moves smoothly through the water, so an engineer might try to mimic this by designing a blade that will move smoothly through the air. How you manufacture the blades is a question that engineers are constantly trying to solve. You will be printing your blades using a plastic, but in real life, materials engineers work to make lighter and stronger materials, and the lighter the blade, the faster it can spin, and the more electricity you can generate. Lastly, you want to think about the number of blades, because the efficiency of the turbine will change depending on this. We do have some design requirements. The maximum turbine blade length is 200 millimeters, and you may use 2, 3, or 4 turbine blades. Now, I will go through some tips in Tinkercad.